Hello everybody. Today we are going to be learning about piecewise functions, specifically how to graph piecewise functions, but also how to tell equations from graphs of piecewise functions. So we have a piecewise function is defined as a function that uses different rules for different parts of its domain. And a key part in this example that we're first given here is this transition point that I see highlighted. So a piecewise function has different parts for different parts of the domain. So in this case, this is a linear graph, 3x plus 4, when x is less than -1. So that's this portion on the left. You see it ending in an open circle here. It's a quadratic, given by this equation here, when x is greater than or equal to -1. So we see a closed circle here, and then a quadratic graph, everything to the right of -1. All right, so that's the basics. Let's see how graphing it looks like when we're given just the equation. You should have a note sheet just like this you can follow along with. So when we're trying to graph this, we have two pieces of the equation, and the transition point is at x equals 3. So the easiest way we're going to do this is we're going to make two different t-tables. So my first equation, I will do all in blue, is going to be a linear equation when x is less than 3. So I'm going to make a t-table here with x and y values. And above it, just so I can kind of make it a little easier for myself when plugging values in, I'm going to write the equation 2x minus 5. All right, now I got to think which x values I want to apply here. This is when x is less than 3. So it's not technically included, but I still do want to include it on my table. The reason why is because, remember from that first example, there will be an open circle at x equals 3 in that equation. So I sometimes draw a little open circle next to it so that I just remember there's an open circle at that value. And then I want values less than 3. So I'll go 3, 2, 1, 0, -1. 5 values should definitely be plenty to get what that graph looks like. And all I need to do then is plug those values into my equation. So 2x minus 5, I plug in 3, 2, 1, 0, -1. And there are my coordinate points. I can start by graphing that. So I'll be at 3, 1, and have an open circle. Then at 2, -1. And so on. That is my line. Now notice how I just draw this graph going to the left forever because it's when x is less than 3. So I do not want to cross the x equals 3 kind of vertical line. This is not an asymptote, but sometimes it's helpful to visualize. Just like lightly draw in a line there. That's like a fence. Neither graph is going to go past it. They're both going to approach it, but they're not going to go past it. And I'm going to do the same thing for the second equation. So I write my equation there, and then below it, I'll write a t-table and plug in the values that I want. The values that I want here are when x is greater than 3, greater than or equal to 3. So I'm starting at the transition point again, but this time at the transition point will be a closed circle. And then I want values greater than 3. Again, 5 should be plenty. There's no set rule, but 5 should be plenty. And then when I plug them in, and be careful with your order of operations here. Remember, you're subtracting 3, then squaring it, then putting a negative on front. And notice my last point there, 7, -13 is going to go off the graph, so I'm not too worried about it, but I definitely have enough to get the shape of my graph. 3, 3 is the first point, and it will be a closed circle. 4, 2. And there's our graph. Notice again that green line I drew in, it's kind of like a fence. The graphs do not go across it. They go to it, but they do not cross that line. And this graph is not continuous because I would have to lift up my pencil to draw the entire thing. It does not connect there at that transition point. All right, first graph down. Let's try another one. All right, we're going to do the same process. So the first piece of the equation, now keep in mind the transition point here is at x equals 2. So I can go right into my graph and say, all right, here's my fence. Here's the line, the wall. It will not cross. It will approach, but it will not cross. First equation. I write the equation out just so it's easier to plug in. Then I want values less than or equal to 2. You're always starting with the transition point. So before you even consider which way you're going, start with the transition point, and then values less than 2. All right, so I'll do 1. Go to -2. Now I can plug those in. And when I plug them in, I get those values, and I can graph them. Closed circle this time. Notice how, again, this is a quadratic, a parabola, but there is not an arrow continuing it to the right side because the transition point, it does not go beyond that point. All right, now I want values where x is greater than 2, but you must include the 2, even though it's not technically included on the graph. There's going to be an open circle there. And I want greater than 2, so 3, 4, 5, 6 should be plenty. And I'll plug each of those values in and see what I get. All right, now this is my open circle at 2, 2. And then notice how this is a linear equation. So it's just going to continue in a straight line. And there's your graph. So we had, again, a quadratic and a linear equation. Again, it's not continuous because I would have to pick out my pencil to draw the whole thing. It does not connect at the transition point. It doesn't hit the same point. All right, let's graph one more together here. If you want to give it a try yourself, first just stick with me to set up the tables because this time there's three pieces here. So there's going to be 3 tables. First table is going to be x squared. It's x squared when x is less than 2, must include 2. Don't forget that. Common thing to forget. Don't forget to include 2. It will be an open circle though. And then I want less than that, so let's go to 1, 0, -1, -2. That's the first chunk. Second chunk is the equation just 4. And I want x values that go from 2 to 6. So I'm just going to really simply put in 2 to 6. And I'll fill in the middle. So 2, we're going to go 3, 4, 5, 6. And here's where it's important now. Notice how 2 is included on this middle inequality, but 6 is not. So 2 is going to be a closed circle, while 6 will be an open circle. Not to be confused with 0, but open circle. All right, setting up my third table then really quick. 10 minus x. And here I want values where x is greater than 6. All right, easy enough. 6, 7, 8, 9. I think that's going to be plenty because I know that's going to be a linear equation. And a closed circle at 6. All right, let's go through. Why don't you take a minute to plug in these values? I'll do the same. All right. And when I get to graphing now, before I go for it, I want to think about these transition points. Again, your graph should have like kind of a change, a transition at 2. Draw a little vertical line. Again, not an asymptote, just helpful for me to visualize it. And then another line at 6. So I'm now separating the domain of this graph into 3 chunks, the left, the middle, the right. And I'll graph each equation on each of those chunks. All right, I have my graph. If you need a moment to finish yours up, feel free to pause. But one thing that you're noticing probably as you're plotting these points is that you have an open circle and a closed circle kind of on top of each other at the exact same point. As we see, it happens here, 2, 4, and 2, 4, and then 6, 4, and 6, 4. So what's happening here with my colors, I can kind of demonstrate it, that a closed circle is essentially filling in an open circle. But if you have a pencil, all you have to know is that in the end becomes a closed circle for each of them. And this is why it makes this equation a continuous piecewise function, because the entire thing connects. You can draw the entire thing without lifting your pencil. All right, so at this point, that's the end of graphing for what we will do together. You can refer to the back of your piecewise functions worksheet number 1 if you want more practice with it. It's a little tight, so you can do tables on a separate piece of paper. In the next video, we'll go the opposite way of telling the equations from graphs. Keep up the good work.